Hey guys, so this is just going to be a quick tutorial on basic Eagle workflow here. So we're going to basically create a board, we're going to create a schematic for it, we're going to send it off to the fab, and just going to kind of walk you through the basics of how to do a super basic project. So once I open up Eagle here, I'm going to go to File and New, and go to New Project. And this will create a new project. It's going to insert it under this Eagle folder here. It's going to call this example for now. And then once we created that, we can either right click on this and go to New and Schematic, or we can actually go to the File, New, and Schematic as well. And that's going to create a new schematic within our project example. Alright, so once we have this new schematic view, there's a few things we want to do to kind of set us up for a better experience. First thing we're going to do is we're going to click on the grid settings over here, and this changes our it gives us basically a display grid that shows us where our objects are going to be snapping to. And it's just a little bit easier to work that way. I personally prefer the dot grid as opposed to the line grid. It sort of gives me what I need but doesn't get in the way, but it's really personal preference. One very important thing about the grid though is you do never ever want to change the grid once you're in schematic mode. And that's basically because all the components are snapping to the default grid here. And all the libraries for the components are designed with this grid in mind. So if you change this grid, your components won't line up and you won't be able to connect anything. So just don't ever change it. Alright, so we changed the grid and you can see we have these nice lines here now. So the first thing I'm going to do is I'm going to add the shield component for the Arduino. And with Eagle, basically the best way to go about things is typing in your commands instead of using the GUI. And it tends to be a little bit faster and it tends to be a better workflow. And this has to do with the verb-noun control structure of Eagle. So what I'm going to do is I'm just going to type in add and then press enter. And this is going to bring up the add component dialog. So once I do that, basically I have my own little shields that are in my own library called Nathan's Arduino Shields. You can see that library isn't available here. And this is something that will come up relatively often in Eagle. So basically what we have to do is we have to explicitly tell Eagle to search for my library. So we can do that by going to Library and go to Use. And then it's going to open up a dialog window here, and it's going to show me basically it's going to move me to the Applications Eagle LBR folder, and that is basically where you want to put all of your different libraries in Eagle. So what I'm going to do is I'm just going to hold down Shift, and I'm going to select all of the libraries that are in here and hit Open. After doing that, all the components that are within those libraries will now be available for you to use. So I'm going to hit type in add and press enter again. It's going to bring up the dialog box. And you can see now Nathan's Arduino library is included with the different components you have available. And this is a nice way to actually hide certain libraries. Sometimes you will get tons and tons of libraries and very specialized. Sometimes it's good to just have one specific, just kind of daisy pick the ones you want to use. So I'm going to open up the Nathan's Arduinos here. And then under Arduino R3 Shield, and it says Revision 3, there's a few different versions of the shield. And you can see I've gone into here and I've added certain silkscreen information to certain ones, other ones I've taken away. For this project, we're just going to go with the most super basic one, this first one right here. I'm going to click OK. And then you can see that the component is attached to my mouse here, and I can just click anywhere to place it. So there we go. We have the Arduino shield there in our schematic. Now one thing is that the name J1 doesn't really mean much to me. So one thing I'm going to do first is I'm going to actually change that name. And I can do that by typing in name and pressing enter. And that gives me the name tool here. So that was my verb, and now my noun is whatever I click on. So the thing that I click on next is the thing in which the name operator is going to affect. So if I click, and with all the components, there's usually a little kind of crosshair in the middle, and that's basically the origin point for it. So if you want to select a component or click on a component, that's where you're going to want to go. So I'm going to click on the center there, and it gives me the option to change the name. So I'm going to change the name to Arduino Uno Shield. Why not? All right, wonderful. So next, what we want to do is we're going to add a switch. Now, I can go to add, and I can search for a switch, and it's going to give me a few options. Now, all these switches that it gives me, though, it's going to have a few ICs, but okay, so that's like a switch there. So, but all these switches is going under the assumption that you're going to actually be soldering the switch directly onto the board, and the switch is going to be attached to the board, which is generally kind of a design convention you want to sort of shy away from. So actually, instead of going in here and using one of these switch footprints that they have available, we're going to kind of create our own. So instead of searching for switch, we're going to search for header. which is going to give us a list of all the different headers that are available. So these are kind of different types of Molex connectors we have here. I'm going to close that. But if we go down to these M0, M2, M3, those are basically your standard headers. And then the number afterwards has to do with how many of those headers are in a row. So we're going to use a switch. We're going to assume that the switch basically has two positions. So the switch is either off, and the two leads to the switch are not being connected, or the switch is on, those two leads are being connected. So basically, we're going to need to create two different pads for us to interface with the switch. So if we go down here, we can find these sort of basic pads that follow the 0.1 inch spacing convention that is most common in PCBs. So I'm going to choose this one because it has a nice sort of silk screen around the outside there. And I don't really think that I need the kind of extra copper that this one is going to give me. So I'm going to hit enter or press OK. And that's going to give me that header. So I want to attach this header to my digital pin 2, and then also have the other side going to the power connection, right? So I'm going to place it down here. I'm going to type in name and click on it so I can change the name of it. I'm going to change it to LED switch. Wonderful. And then I'm also going to need a current limiting resistor as well as a pull down resistor for the switch. That way we can do a little bit of hardware debalancing and make it a little bit more stable. So I'm going to type in add again, and I'm going to search for resistor. Now one thing that is important to note about the sort of add interface here is it's pretty much the dumbest search you can ever possibly do. So see, I type in resistor and I got these different types of resistors, but what if I leave off the R? And if I only type in resisto, it's going to return absolutely nothing. Because it's actually searching for an exact string match of resistor, and if it doesn't find it, it's not going to return anything. That means, although I'm searching for RESISTO, which are the first letters in the word resistor, it's not going to find resistor unless I put a star behind it. If I put a star behind it, then it's basically a wild card, and it knows that it can throw in any sort of character there to complete the word. And the same goes for the front. So I can actually delete this first R, put in a star in there as well, search for star, isto, star, and it'll give me the same results as well as actually an additional few results. And that would be because sometimes it will actually have a capital R instead of a lowercase r. And it will, I believe it is case sensitive. So anyways, oops. Resistor, all right. So I usually tend to use the SparkFun components, but it really doesn't make much of a difference. And I'm going to kind of scroll down these. These ones with the red pads that are kind of square, those are surface mount resistors, and we don't want those. That means that it doesn't have leads you solder through the board. You only solder it to one side. So those are more difficult to deal with, and they're actually not as reliable and fail more often than through holes. So we're not going to use those. So here we have all the through holes. As you can see, there's tons of options, tons of different sizes. Now basically the standard is this sort of Axle 0.03 kit. So that's what we want to use. And there's a few little options for it. There's this one, and that one. It basically comes down to how you want the silk screen to be displayed and which one you basically just think looks better. So I'm just going to kind of pick this one with no real reason to do it. Excellent. So I'm going to put a resistor in between the D2 pin and our number 1 pin on the switch. And I do that just by clicking, and it's going to assume that I want to place more resistors. But actually I do, because I want to add a pull-down resistor as well to do some hardware sort of debouncing there. So I'm going to place that as well. Now, what if I kind of want to move my switch is a little bit closer to these resistors, so I do that by using the move tool. Now of course I can click on all these sort of icons in the panel here to the left, but it's much easier and you'll end up kind of liking Eagle more if you just type in move instead. So I'm going to do that. There's my verb. My noun is the switch. So I click on it, and then I'll just move it kind of 2 clicks over. All right, excellent. Now, the other thing that we want to have is we want to have that LED, right? Now, the same thing with the LED. We don't really want to have it directly on the board. We want to have it, like in the casing for our interface. We don't want to have it soldered onto the board itself. So we're going to use the same technique that we use for the LED switch over here, of basically using the header pins instead of the actual footprint of the component itself. Now instead of going in and typing an add and searching for a 2-pin header, the easier way to do it is actually to use the copy tool. So if I type in copy and press enter, that'll activate my copy tool over here. And then any component that I click on is going to create a copy of that component and attach it to my cursor where I can then place somewhere else. It's a little bit different than copy in other programs. Now the advantage of doing this is that I know that all of the headers that I use in this schematic are going to be the same. And if I do the same thing for the resistors, I know that all the resistors are going to be the same as well. So this will help alleviate any issues of like, oh, well, I used the right type of resistor for 9 out of my 10 resistors, but the 10th one I accidentally grabbed this big giant package that I didn't actually mean to grab. So in general, if you have the component already in the schematic and if it already exists within your project, you're going to want to copy it instead of creating a new one. So now that I have the copy tool, I'm just going to click on this sort of center crosshair of the LED switch, and it's going to create a copy of it. This is attached to my cursor, and I can then move around and put wherever I want. Now, on this schematic representation of the Arduino Uno, it designates which one of our pins are pulse width pins by this little star next to the number letter designation there. So you can see D3 has a little star on the left-hand side where D2 does not. And that basically means that D3 enables pulse width modification, while D2 is just a normal digital pin. So I'm going to want to hook my LED up to a pulse width pin because I want to basically make it get a little bit brighter and a little bit dimmer. So I'm going to stick this basically down over here. I'm going to attach it to D11 as the main pin that powers the LED here. Now I'm going to type in name and then click on the center of it as well, and I'm going to change the name of it to LED because this is going to be our LED here. Now our LED as well is going to need a few resistors, or actually one resistor to limit the current to make sure we don't blow it out. So I'm going to use the copy tool by typing in copy and pressing enter, and I'm going to click on one of these resistors. And it's going to copy that resistor and give me a second one. It doesn't really matter if we put it on the negative or positive side, so I'm just going to put it on this second pin here. Wonderful. Alright, and that's actually all the components that we're going to need for this circuit. So the next thing that we have, now that we have all the components placed, we're going to want to actually connect the components. Now you're going to want to use the net tool for this. The net tool is what you use in Schematic View, and you use the route tool in Board View. So I'm going to type in net and press enter, and that's going to give me the net tool. Now this allows me to click on any of these sort of leads here, and it gives me my drawer, and then I can click on the other end of the component and attach those two components together. And the way that I know that they're connected is I can use my move tool, and I can click on the resistor, and if I move it around, you should be able to see that trace sort of stretch like that. And that means you connected it correctly. All right, and then so I'm going to hook up the rest of these. I'm going to type in net. I'm going to click here, those are connected, and click on the bottom, connected to this resistor here. And then I'm going to give myself a little bit of a lead to attach to the ground. And actually, so in order to add the ground, I'm going to type in add here and press enter. It's going to open up our component searching dialog here, and I'm going to type in GND, which is the short for ground here. I'm going to grab this ground here, so that's a ground symbol. The other one will have the 3 lines kind of getting smaller underneath each other. They both mean the same thing. I'm going to grab that, and I'm going to click it on the bottom here. And it's going to ask me if I want to rename net segment N4 to supply pin ground. Basically what that's asking me is whether I want to actually connect this net, which is the line that's connecting the things, to ground, which I do want to do. It's an intentional thing, so I'm going to hit OK. And it's going to do is going to plop it down right there. All right, and I'm going to type in net again. I'm going to hook up our LED on the bottom. And then in between, I'm pressing escape to deactivate the tool. I'm going to give myself a little lead here. And I'm going to use the copy tool to copy the ground that we placed, give us another one, and pop it in right here. And it's going to ask us again, hey, do we want to rename this? And yes, we do. Alrighty, so now that we have things wired up, we're going to kind of give a little overview of what's going on here. So we're going to look at our LED. So our digital pin 11 is going to power the LED. That goes in here. We have our current limiting resistor going to ground. meaning that when the digital pin is high, then our LED is going to turn on. Great, everything checks out. And then we'll check out our switch. All right, so digital pin 2 is going to read the switch. That has a current limiting resistor going in. On the other side of the switch, we have another current limiting resistor going to ground. Wait a second. Well, that's not exactly what we want, is it? Now, the resistor is in the wrong place. There's no reason for us to have two current limiting resistors. What we actually want is a pull down resistor instead. So we made a mistake. So we're going to go in and we're going to delete the components that were placed by accident. Now in Eagle, you don't really want to like move things and kind of try to pick up the trace and then reattach it. It's going to run into issues and things not actually being connected. So if you do make a mistake like we did here, then you're going to want to just delete what the mistake is and then replace it again. So I'm going to type in DEL, and that's going to bring up our delete tool. You can also click on the trash can if you're so inclined. And then I'm going to delete this resistor, this line, and this ground. Now, I'm going to use my copy tool. I'm going to copy a resistor. I'm going to place it where it should be. And the resistor should be basically here. And it's going to be attached to a ground port as well. So I'm going to type in copy. I'm going to click on the ground over here. We're going to type in net, and it's going to give us our net connections, and then we're going to connect the resistors to the ground there. Now you notice that it made this little dot here, and this is actually right over here. It's a net junction. And what that dot says is it says, hey, all the lines that are terminating within the dot that I am, they're all connected to each other. So that dot tells you that R1 is connected to R2, which is also connected to this pin right here. So this is sort of a nice little reminder that tells you what's going on. And it makes a little bit more sense if you have a situation like this. So I'd say I have a net that I'm connecting to a component over here, and then it's also going and connecting to a component down here as well. Now if I did that, although these two lines are crossing over each other, they're not connected. There's no electrical connection happening there unless I place a net junction in the middle. And then it's going to ask me what I want to call this connection, because one of them is called N1, the other one's called N4. So since these two junctions are going to be connected, it wants to know if I want to call the resulting connection N1 or N4. I don't want to do that. We'll just hit cancel and then undo here, which is Command Z. Now another interesting thing to note about nets is you do have different routing options. So by default, it'll basically give you that right angle turn on the side where you started. Now if you click with two fingers on your trackpad or use the right mouse button, it'll actually toggle between different routing options. And it'll keep on toggling until it goes back to the beginning one, and those can naturally be displayed right up here. So if you don't like the right angles, if you want something a little bit more sleek or something very direct, then you have options over those different routing options there. All right, wonderful. Now we're almost done for our LED switch here. The only thing that we're missing is we are missing power. So we're going to type in add, and then we're going to search for 5V. So 5V will give us one of these power supply signals. So we're going to click OK, and this is the signal for power, just as this is the signal for ground. We're going to click on the end here to attach it. And yes, we want to rename it to 5 volts. It was intentional. And bam, there we are. Now if we want to kind of do a quick little double check and make sure everything is connected, I can kind of pick up a component, move it around, make sure it's dragging these traces with it. And that just gives me the confidence that things are connected as they should be. All right, wonderful. So let's say that we want to have a little bit more descriptive names for these resistors. So if I type in name, and if I click on the resistor, then it gives me the option to rename it. So I'm going to rename this to R, let's see, we'll do it CL1 for current limiting, or CLR1, current limiting resistor 1. We'll call this CLR2. And then this guy right here, we're going to call it PD for pull down R01. Now this isn't really convention. People usually just leave it as R1, R2, R3. But if you feel so inclined to kind of give things a custom name, then you are able to do that as well. So there are a few connections we actually do have missing with this board at this point. So one thing is, although we do have our switch attached to our ground bus, the ground bus is actually not attached to the ground for the Arduino. So if I bring up the copy tool by typing in copy and pressing enter, then I can copy our ground right here. I can flip it over and put it to the side. So if you right click, then it allows you to rotate your item by 90 degrees. And I'll place it down here. I'll type in copy again, and also copy the 5 volts. We have the same issue with our power plane as well. It is not connected to the Arduino. So I'm going to place that over here. I'm going to type in net to bring our nets in. I'm going to connect these two guys together, and connect the ground to the ground as well. Alright, I'm going to bring out the move tool. I'm going to pick up the Arduino and move it around. Alright, things are actually connected how we expect it to be. Alright, fantastic. So that's basically it for the super basic side of things for the schematic view.